do 10 high-level science experiments using water, detergent, and everything. Super easy for you to do at home. Deal. Who's with us in this video? Finish Quantum, an exclusive dishwasher detergent. It's relevant today because cleaning is Finish Quantum's main function. But it's also all about having fun, which is a suggestion for what you can do with the extra time in your life when you use dishwashers and don't waste time at the sink. Let's go. So the first one is the square soap bubble. You have to make a cube out of straws, cut 12 equal parts, and use a wire structure. Add epoxy putty to the corners to maintain the 3D shape and paint it for a better appearance. The effect is really cool, and it stays in this square shape because the edges of the cube pull the film that forms the bubble. It ends up creating a second cube inside. The next one is really beautiful. It's the soap bubble with dry ice. You'll need a plastic bottle, a plastic cap, and a little hose. I'm going to make a hole in the bottle cap, fit the little hose in tightly, then seal it with hot glue. On the other end, it's the same thing, just with another cap. And now comes the fun part. This here is dry ice. It's carbon dioxide, it's carbon monoxide too in its solid state. But there's something cool about it. It turns into gas without going through the liquid state. This is called sublimation. Look how beautiful this is. But the coolest thing is that this is a special bubble. It doesn't pop so easily if you put it on a wool surface. Music. If this isn't worth a like, I don't know what is. Music. The next experiment also has to do with carbon dioxide. It's the floating bubbles with baking soda. Before that, I wanted to ask you something. Right? Is that disgusting liquid you're using to make soap bubbles like spoiled peach juice or something like that? This is a special liquid for making soap bubbles, which we taught how to make on Manual do Mundo when we made the giant soap bubble. And yes, it has soap in it. And we made it around 2012, 2013, around 2012, 2013. I get it, I won't change the subject, right? To do this experiment, you need an aquarium, vinegar, and baking soda. I'll put baking soda at the aquarium's bottom, then pour vinegar over it. These bubbles that are appearing here are carbon dioxide. It's one of the products of the chemical reaction that's happening. But carbon dioxide is denser than air, so it will stay at the bottom. It will stay in this lower part of the aquarium. If I blow a bubble full of air, the air is lighter, less dense than carbon dioxide. Theoretically, it will float. I just have to hit the aquarium, preferably. I think I was a bit stingy with the vinegar. Let's go all out now. The chances just got better, right? Wow. The bubble is floating. Let's add a bit more carbon dioxide, right? The next experiment, I won't even count it in the numbering, okay? Because it's going to be a bonus for you. Water molecules want to stick together. They're attracted to each other. And this ends up forming a film on top of the water, which we call surface tension. That's why when I sprinkle oregano on top, it doesn't sink. But what's cool is that detergent breaks the surface tension. It breaks that film. It's like the water gets even wetter. So if I put a little bit of detergent on the tip of my finger and touch it there, it will break the surface tension right in the middle of the plate. In practice, look what happens. What happened here is like the molecules were pulling each other in a tug of war, and the detergent comes in and cuts the rope. Each one goes to a different side. Next experiment then that uses surface tension is stacking drops on a coin. We did this in 2011, and I managed to simply put 42 drops of water on top of a 5-cent coin. It seems impossible, but it's not. But one thing I didn't do at the time is ruin this experiment, which is to lightly put a little bit of detergent on top of the coin. And now, how many drops do you think I can accumulate on top here? With almost no surface tension? About 20 at most. Another really cool experiment, which is the effect of surface tension, is the magic touch. You take a very thin wire, 0.7 millimeters, bend it into a spiral, and make it very flat, very straight. Then you run a candle along one side of the spiral. Place a piece of toilet paper on water in a plate. Then set the spiral on top with the candle rubbed side facing down. Then you gently press the toilet paper down so it sinks, and only the spiral stays floating on the water, on top of the surface tension. And look what happened. When you touch a stick with some detergent on the tip to the surface, the center's tension weakens, and the outer tension pulls the spiral, causing it to spin. A kind of magical thing about detergent is that it has the ability to like two opposite things at the same time. One part of it likes water, and the other part likes fat. The detergent molecule has something like a head and a tail, and when it's in water and comes into contact with fat, the tail part attaches to the fat. We call this a micelle. It's like the soap forms tiny little packets stuck to the dirt, just waiting for the water to come by and wash them away. And a very important experiment that uses this interaction between fat, detergent, and water is taking a shower, for example. We use soap because it binds to the fat that's on our skin, and then the water washes everything away. But for a science fair, there's another one called psychedelic milk. You put a little milk on a plate, then spread a few drops of food coloring, and add a bit of detergent. This psychedelic effect is the fat in the milk and the detergent interacting. After all that, you can already get a sense of the chemistry that happens when we wash the dishes. And this here is Finish Quantum. It's a dishwashing detergent that comes in tablet form, and you put it just like this inside the dishwasher. Inside there are substances that will do exactly what we just saw. One part attaches to grease, the other to water, helping remove dirt. But that's not everything. They have a formula made specifically for dishwashers, which besides being able to remove tougher stains, also leaves the dishes sparkling. And anyone on the other side of the screen who knows me knows that I don't even have a dish rack at home. If there's one thing that's good for a couple, it's not having to wash the dishes. But hold on, there's more experience coming. You'll see even more of the onion's DNA. This experiment uses chilled alcohol, left in the freezer overnight. You're gonna cut an onion and put it in a glass with water, a spoonful of detergent, and a small spoonful of salt. Cover it with plastic and put it in a double boiler on low heat for 20 minutes. While it's still hot, you pour all of that through a coffee filter. Cover the filtered liquid with plastic and put it in a container with ice for 5 minutes. Then mix it very slowly with the alcohol, and after about 5 to 10 minutes, those little things that start to rise are nothing less than the onion's DNA. The next experiment is the storm in a glass of water. This one is on the cover of our first book, the old edition, and we've never done it on the channel. First, I'll cut out a picture of a dark, stormy landscape and stick it outside the glass. Next, I fill the glass with water, leaving some space at the top. About 3 drops of dish soap and a full spoon of salt, and also a few pieces of plastic. Salt is added to increase surface tension, slightly reducing the dish soap's effect and limiting bubbles. Now, spin it to form the tornado. Music. The next one is how to keep the bathroom mirror from fogging up. You're going to put a little bit of dish soap on a piece of toilet paper and then wipe it on the mirror. You don't need to leave a thick layer of soap. On the contrary, it's a thin, invisible film. You won't see anything after you apply this. It won't let those little water droplets form that fog up the bathroom mirror. The water will spread across the glass. I showed this experiment for the first time in 2013 when I had a kidney stone in Rio and was hospitalized. Let's see if it works here too. Music. And the last experiment is the stain that disappears. You will need 2 glass cups. I'm going to use 2 beakers here, which are these laboratory glasses. One has to fit inside the other, leaving about a finger's width of space between the rim of one and the rim of the other. To center it well, I'm going to use 3 clothespins on the beaker in the middle. Add some white paint and water to create a white background for the experiment. And in the space between the two, I'm going to fill it with clear detergent. I've already prepared 3 small containers with detergent and dye. It's a colored detergent. My challenge now is to inject a line of dye here between the 2 beakers. I have to try to do this without making too much of a mess. And now here's where the magic happens. I'm going to spin the middle beaker. Look what happens. Nothing special, right? Now I'll spin it differently. Music. You thought it was already a mess, right? right? But not the layers of liquid, they stay the same. Detergent is extremely viscous. It's a thick liquid. So here you think you've already mixed everything, that it's all lost. You won't be able to tell which paint is which anymore. But no, when we reverse the experiment, you start to see that in the end, the colors didn't mix. Of course, over time, they do mix a little bit, but you can turn it back several times, and you can still see the colors. Let's be honest. After so many experiments with water and detergent, it was easy to understand that it breaks the surface tension and can bond with both water and fat at the same time, carrying away the dirt. Not to mention that now you have a complete list of experiments to do at the science fair, right? If you have a dishwasher at home, the tip is to try Finish Quantum so you can find out in practice what its benefits are to get your dishes really clean. Music. A lot of people ask a question, which is, why is the foam white if the soap is sometimes colored? The answer isn't that simple, and we made a special video just to explain this.